Hey fellow engineers, welcome back to the channel, and today we are covering retry patterns in microservices, or what you may traditionally know as retry mechanism. But before heading on to the video, I would sincerely like to thank you all for helping me cross 100 plus subs. Although not a big number, but I'm seriously overwhelmed, and all the amazing comments that I've got are really overwhelming about how I should prepare my videos, how they like my content, and different ideas. I'll keep each one of them in mind and make sure to work upon them. Also, about me not being able to post for the last 2 weeks, that's because I was in my hometown, stuck up with some work. But now we are back on track, and I'll hopefully keep on posting on regular intervals. That is most probably the end of week. And so yeah, here we are. Let's head on to the explanation for retry patterns. So what are retry patterns? Imagine calling a friend or a family member, and they don't pick up the call because they might be talking to someone else, or maybe the network is congested, network drops, whatever. You try to hit them up again after some time, after a period of time. It could be 10 minutes, 5 minutes, or even an hour, whatever. And again, they don't pick up the call. So you retry again, and finally they pick up the call. So the call was eventually successful. Now, this similar pattern that you performed is a retry pattern. So here in the situation, you were the initiator for this retry pattern. Now, in the world of internet, when we deal with backend services and microservices for that matter, we usually rely on these retry patterns to, make the service more reliable. There are some errors or faults that can be handled just by giving the service another chance. That is, when we're talking about microservices to be precise, or even in monoliths, when we try to call a third party API, maybe a weather API, whatever, you can't rely on a service entirely, because the network could drop, or there might be some rate limiting happening in the service or whatever. So you sometimes need to retry again to make the request successful, because that is not a hard error, right? That is a situation based error, or a temporary error that can be resolved by just mere retrying. So we have these reliability patterns. Yeah, this falls under the reliability engineering part of backend engineering, and these retry patterns helps us to make the system more fault tolerant when we are talking about microservices or even monolith, as I said. So as you can see in the example that I've given here, this diagram, the client is making a request to the server endpoint, and the server is returning a response. It could be a success or a failure response. Now, if it is a success, we conclude the request that it is successful. But what if it fails? Now, if it fails, we ask the question, can we retry? Now, what does this mean? Why do we ask, can we retry? Because the failure could be many things. It could be a hard failure, like input failure, or maybe the internal server error, whatever. We don't want to retry that kind of request, right? Because we know it is a hard failure and it won't just fix itself by mere retrying. So we need to fail it. But how if it is a temporary failure, like a rate limiting failure, too many requests, or bad gateway, or maybe just a network drop? It can happen, right? So in that situation, we can say yes, we can retry. And even, yeah, we can have a maximum count, the number of count to which we can retry. Let's say 5. After 5 attempts, we will consider the request as failed. Yeah. So in the scan retry part, we also ask that are there retry attempts left or not. If yes, we move further. Now, now we wait for some time. We don't immediately retry the request, because if we immediately retry the request, there are chances that the server was still asleep, or there was some error going on. So we eventually wait for a few seconds before retrying again. Now that delay is based on the different type of retry patterns or different algorithms that go within it. We'll discuss that later, but for now, let's say for n seconds we wait and retry again. So yeah, after n seconds we hit the request again, and based on the response, we either consider it success or failure. Now, going by a slight bookish definition, in distributed systems we have multiple microservices interacting with each other. And while this interaction happens, one service tries to call another service, it is highly likely that a request might fail. or a call might fail to a different service. And to deal with such situations, we have this system design pattern, or you may call it a reliability pattern, to deal with these transient or temporary failures. Now, these patterns, these system design patterns, are known as retry patterns, and they help us to make the system more fault tolerant and more reliable. Now, to be precise, the definition goes like: to address transient failures in microservices, the retry patterns involve automatically retrying a failed request a predetermined number of times before considering it a permanent failure. Now, what does it mean? That to deal with these transient failures that occur between microservices during the contact, uh, a retry pattern usually comes into picture where it automatically retries a request a predetermined we can have a fixed count, as I told you earlier. We can have a fixed count like 5 attempts to retry a request, and that predetermined number of times it will try to retry after it will fail. So these predetermined number of times it will try to make the retry call before considering the failure as permanent. That's what the definition is all about. Now, to gain familiarity with these retry patterns and how to implement them, I believe we should try to implement the most basic form of retry pattern right here on this board. And so, yeah, let's try to implement the most basic form of retry pattern. So let's start by defining a function. We'll call this retry. Okay, so we have this retry function here. Now, within this retry function, I would say we'll have something like a max attempts. Okay, we'll have max attempt as 5. Now, these max attempts are the predetermined number that we talked about here. These are the max amount of times we are going to retry a request if it fails. So also for a retry pattern to work, we actually need something as basic as a loop. That's it. Retry patterns are nothing but a mere loop that is going again and again till either the maximum attempts are over or we get a success response. So we'll go from 0 to max attempts. We'll go from 0 to max attempt to retry a call. Okay, now we have created this loop, and within this loop we'll try to call a service. So we have imagine a function called service which will call a different service and return us the response. So we'll just save the response as well. Now we have the response, right? So now if this response is a failure response, we are supposed to retry, right? This is going to be a pseudo code. Don't expect me to write the perfect Python code here. So with this response, we'll check if the response dot success equals false. That means the request failed. Okay, so we'll try to check if the request has failed. That means the response is not successful. And if that is the case, in that case we'll do something like check if the response dot status falls under a set of retryable response statuses. Now we have not defined any form of response statuses that we are going to retry for, so we'll create an array. We'll create a retry array which contains all the form of status codes that we are going to retry, because we don't really want to retry all the form of requests, right, as I told you earlier. So for now we will just try to look out for 429, that is too many requests, 502 and 501, that is bad gateway or network error related requests. So, and also 503 probably. Let's look at the different type of request statuses. What is 501 and 503 status code? Not implemented and service unavailable. Okay, so it is going to be 503 and 502, not 501. Okay, yeah. So for 429, 542 and 503, we're going to basically retry these calls. Now if the success is false, we check if the response status falls in this retry array block. If it does, we basically just continue. That's it. But if it does not fall under the given retry array, we'll just make a failure response. We'll maybe even raise an exception. We'll just raise an exception saying request failed or something. It should be more detailed, but we are just doing a raw attempt, so yeah, it's fine for now. So we have created this retry array, retry function, in which we have a max attempt, the amount of time we are going to retry. We have a retry array which contains all the status codes that we are going to look out for trying to retry. And then in the loop we are calling a service, checking if the response is successful or not. If it is not, we check the retry status. If it falls in this array, if it does, we continue, else we throw an exception. But what if the request succeeds? If that is the case, we simply return the response. That's it. So this is what a typical retry pattern looks like, except the part that we are not considering delay for now. As I told you earlier, we have delays here as well, right? We talked about this delay, but we have not considered it in this picture that we are drawing here. That is because we want to look out for the most basic form of retry pattern that we can implement. And so this is to gain familiarity of how to implement these retry patterns, so when I go a level further, it does not feel unfamiliar. Okay, so now let's head on to a playground that I've created to test these different retry mechanisms and talk about different patterns. We'll head on to the code and see different type of retry patterns and what I've created, and we'll discuss about each one of them. So first of all, I've created this particular route here. Now this route is called as unreliable because this is an unreliable API, as I call it. It basically randomly generates different type of errors while also being successful at times. So if I try to run it in Postman, you can see it keeps on throwing different type of errors, and in between it also gets successful. It is totally random errors and random success response. So this is how it works. This is the unreliable API that we are going to handle using retry mechanisms. Now you can imagine this being a third-party service or a different microservice, whatever, but now we are going to handle it using retry mechanisms. So this is a script that I've written to call this unreliable API using this request module. I've defined a few utility functions that I want to talk about first, and I've also defined some variables. These are constant variables for URL, number of attempts, the predefined attempts that we are going to make for a retry. These are the max attempts. Then we also have a delayed amount of time, delayed seconds. We have set it to 1. You'll know why in a moment. And then we also have the retriable API, which contains all the status codes we are going to look out for to make retry calls. And now about the utility functions that I've created. The first and foremost is the API caller. This will take in the URL with a timeout, which is fixed to 15 if nothing is given. We provide the URL here, and it basically sets the timeout and all, and calls this URL and handles the response as well. As simple as that. Then we also have another function called finished, which basically takes in this response from the call API and extracts the response body out of it. If and only if the status is successful or it is not in retriable, that means a hard failure. So it will simply return the body, else it will return none. As simple as that. So now yeah, let's see another. Okay, I also have this Retry-After wait, but we'll talk about this later. So for now, let's talk about the first type of retry mechanism. That is the most basic form that we also have discussed here. It is the same one, just a bit more professional, nothing else. It basically runs for the max attempts range that we have already talked about, that the max amount of attempts that we can make is 5, so it will retry for 5 times. And within this loop, we simply call the call API, that the utility function that we've created. It will simply call this API URL that we have passed in and extract the body using finished. Now about finished again, this was the utility function. It took the status code and checked if it is a hard success or a hard failure. If that is true, it will simply return the body, else return none. That means if we get a none, we know that we have to retry again. but if we get a body, we simply return the body. That's how the finished function is supposed to work. Now within this call with retry, uh, we get the response in the form of body. Now if body is none, we will simply retry. That means it will continue here. We don't need to write continue because that is the default behavior. But if the body is not none, that means the body has some content, we will simply return the body. That means we have either hard success or hard failure. Now this is wrapped within a try catch block, as you can see. Now this try has the main logic. Now except has first of all the timeout. Now if the exception occurs for timeout, we basically try it again. We are going to try it again by simply again continue. That does not need to be written because that's a default behavior. Now it will retry again within this loop, and if the exception that occurs is request exception, that means it is a request failure, we will simply return none in this case. And if these attempts are over, we'll simply return again none. We can also raise the error directly, but let's not do that for now. We are just trying to keep things simple for this demo. Now this is the most basic type of retry that we already talked about. So now let's try to run it. Now in this particular script, at the very bottom, I have set this up to call this particular function only and nothing else. So we'll get to see the response properly. I have set up a print statement here so we can visualize the number of attempts that it makes. Now let's head on to terminal and I'll just clear it, and yeah, let's try it again. So as you can see, when I hit the corporate retry script, it took 5 attempts to get success. If I try again, this time it worked in just the first attempt. Again it took 5, this time again 1, 5, 2, 3, 1. Okay, so this is working. That's the point. So it is not waiting, it is directly trying again and again until either the attempts are over or the request is successful. Now this is problematic actually. If you keep on repeatedly hitting retry call again and again, it could eventually lead to the server choking. If there is only a single user that is trying to retry, that is for which the retry is happening, that is okay. We can do this as well. But when there are hundreds and thousands of users using a server, there is a chance that multiple users at the same time might face a retry, might face the need to retry to the server. And in that case, you might, want a slight delay, because if each one of those clients try to, retry a request to the server, it might choke up, and that might lead to even worse delay, and which we can't retry. So it is better to have some delay in between to make the retry much more reliable and much more fault tolerant. So that's where we introduce a slight delay. That's the next type of retry pattern. Now this particular retry pattern is actually called a fixed delay retry pattern, the second one that we are talking about. Now what is different here? It is actually pretty much same, except the part that we are going to have a time.sleep function being called at the very end. So everything is the same. So we are for each attempt we are checking the body. If the body is not none, we simply return the body. But if it is none, we know that we want to retry. Now if now there is this particular if statement that says attempt is less than max attempt minus 1. Now what does that mean? It is checking if this is the last attempt. If it is the last attempt, we don't want it to sleep, right? So in that case, we just check if attempt is less than max attempt minus 1, and we'll let it sleep for this amount of seconds. And in this case, we have set it to 1, so it will sleep for 1 second. Now we can have it 2 or 5 seconds or whatever based on the situation. For now, I have set it to just 1, so we can easily test it. Now what will happen is, after each attempt, it will take 1 second to wait and then retry the request again, and this will happen until the request is either successful or totally failed. And again within the timeout, we can also see a similar kind of pattern. We have this line as it is copied here, which means we are in timeout also, we are waiting for delay and retrying again. Now this pattern makes it much more robust. We are having a slight delay between all the users and before retrying all the requests at the same time. So there is a way lesser chance of the server choking up. Now let's try to let's try this in action as well. So I'll just replace it here, and yeah, now let's head on to terminal again. If I call it again, you can see it it took the first attempt, waited for a second, and then it took second attempt, and we got success. We can try again. This time it just worked in the first attempt. 1 2 3 4. Yeah, this time it took 4 seconds and 4 attempts to make the call successful. Now that we have talked about call with retry and call with retry delay, you might have a slight idea about why we need delay. Now, what is the problem with delay? That we have other patterns. Before heading to other patterns, we must understand the problem, right? So the problem here is that when we are dealing with these delays, if we keep a fixed delay all the time, if let's say 100 users face a retry situation at the very same time, each one of them will have the same amount of delay, and when they retry at the same time, it will still keep on choking up the server. Now it might save the server from choking up, because it is very unlikely that multiple people are going to try a same request at the same time. But let's imagine it being a huge server, a huge app, a social media app or something, and we have this retry mechanism involved somehow. Now what if 1,000 people might have the situation where they want to retry simultaneously, and in that case it might fail. So it might end up choking the server, and to save it from that, we have further type of retry mechanisms that move around delay. So how do we implement different type of delays? Now let's talk about the different type of delay based retry mechanisms, which is called call with after. Okay, so now what is this particular type of retry mechanism? Now you can see everything remains the same except this one particular retry after wait call, and that too in the try block, not even the timeout except block. We have simple delay seconds. In the try block we have something called as retry after wait. Now why is that? Let's talk about it. It was a utility function that we had skipped earlier. Now we can talk about it. Now retry after wait takes in the response from the request, and extracts the response headers and look for a retry after header. And if that is available, it will take the amount of seconds from retry after. Otherwise, it will just take in delay seconds and convert it to floating point number. Now, this retry after is something that will be set by the unreliable API itself. If it is your own service, you can do something like that. That the server will give you a particular amount of seconds that you need to retry after. Now, the retry time is basically managed by the API itself. But we can't really test it right now because I haven't implemented the response header. So we can just thoroughly visualize how it works, and that is more than enough for now for this particular case. We'll look others in more detail, but for this one we can skip it because this is something that we have to rely on the API itself. Now heading on to the next type of retry mechanism, which is a much more robust type of retry mechanism, which is called as linear backoff. Now what is linear backoff? With linear backoff, we just keep on increasing the amount of delay time with each attempt. Whenever a retry attempt happens again, we increment the amount of delay time, so that if there are multiple people trying at once, they will each face a different amount of delay time within their server calls, so the server doesn't choke up again. That's the point. So as you can see, uh, we have done something like we take the attempt from the max attempts, the current attempt, and add 1 to it and multiply it to the delayed seconds. So basically it will go from 0 to 5, and we basically increment it by 1, so it will go from 1 to 6 or something. sorry, it will go from 0 to 4, and here we make it from 1 to 5. So delay second is multiplied by 1 to 5, so it will be something like, if we visualize it, it will be 1 into 1 for the first attempt, then 1 into 2, and so on until 1 into 5 happens. And that is the amount of time it will wait before retrying the next request. And it will keep on incrementing after each retry. And similar thing we have done in the timeout, exception handler. Now let's try to run this as well. If I go to the very bottom and change this, now we can actually retry this request. Okay, this worked in the first attempt. Again, okay, you can feel the amount of seconds keeping on increasing after each attempt. They're significantly increasing after each attempt because it is linearly increasing the amount of time of delay. We can again try. This time it worked in 2. Again, yeah, so it basically keeps on increasing the time linearly. That's the linear backoff. Here the backoff represents the delay, and linear is the linear amount of time increments that we do while increasing the attempts. So this is how linear backoff works. Now again, this is a good approach but not the best one, because this can even sometimes lead to the delays are very small, so there are chances that people still keep choking the server. So we have something even better known as exponential backoff. Now what is exponential backoff? Here the backoff backoff delay keeps on increasing exponentially rather than incrementally. So here we are basically taking the attempts in 2 to the power. So in the first attempt it will be 2 into the power of 0, because, or we can even do something like, we can do it like this. So it will start from 1 and go till 5, and it will look something like 1 into 2 to the power of I should use the caret symbol, 2 to the power of 1, and it will go up to 1 into 2 to the power of 5. And this is an exponential delay, and this is much more robust than the linear delay because it gives us much more time to wait between the delays. Now let's try to implement the exponential backoff. I mean, try to run it and see it for ourselves how it works. See, it worked in the first attempt again. Okay, as you can now feel that the retry is much more slower because the attempts are significantly rising. After each attempt it is exponentially rising the number of attempts. That's why it is way slower. And that also you might have also noticed that the number of errors have been reduced, because as the number of delays keep on increasing, it becomes less likely in the next retry that we'll face error again in a real world scenario. In our unreliable API, because it's a random generator, it will keep on throwing the same error despite the delay. It does not matter. But in a real world situation, if you wait longer, there is a higher probability that the next attempt would be a success. So that's why we usually prefer exponential backoff. Now let's talk about the next type of retry mechanism, that is jitter. Now what is jitter and why is it better than exponential backoff? Let's talk about it. So first of all, what is jitter? Now, as we saw in exponential backoff and linear backoff, that the time delay was based on a set of numbers that either was linear or exponential change in numbers, right? But with jitter, there is no predictability. We choose random delays, random amount of delays. If you look at this time.sleep here, this line where we cause the sleep to happen, we choose a delay based on a random integer from 1 to 10. So we are choosing a random integer from 1 to 10 and multiplying that to the base delay, that is the delay seconds. So when we do that, we make this sleep or delay time unpredictable. Why is this helpful? First of all, when there are multiple users on the same server and all of them retrying, and each one of them gets a different random type of random delay number. That causes randomness in the server and helps in keeping the server calm and not causing it to panic. With backoffs, the thing is the amount of the amount of delay is predictable, so everyone will have around about the same amount of delay, maybe a little less or more, but there is a high chance that when there are so many users, they might choke up the server by retrying again and again. But with Jitter, that is not the case. With Jitter, each one of the user gets a random number, a random amount of delay. So with that random amount of delay, no one knows when the other user will, retry the request. So it keeps the server calm. That's the point. But Jitter alone is not better than exponential backoff. Exponential backoff is very powerful, but Jitter has its own benefits. We can't compare the two. But what we do actually in a real world scenario is combine them. We combine exponential backoff with Jitter to make it much more powerful and much more reasonable. But before going to that, we should actually see it in action. So we'll do something like call with Jitter. So I'll run this and we'll see it in action. So where is my terminal? Yeah. Now you will see random delays. I don't know how much delay did it cause. It is stuck. Okay, I guess we should print out the amount of delay it is causing. So let's just copy this and bring this out and delay, and we'll print this delay as this and pass in the delay here as well. Okay, so with this we can actually track the amount of delay it is causing. Okay, it worked in the first attempt. Again, okay, this is giving us a 10-second delay, so it will take a lot of time. We'll try again. Okay, just 1 second delay. Okay, perfect. So 5-second delay this time. Okay, it worked. A 1 second delay, a 3-second delay, a 2-second delay again. Okay, as you can see, the delays are random, so it is unpredictable what amount of delay we'll get next, and based on that we keep on retrying. Now that is kind of cool and it is very helpful, but it becomes more and more robust when we merge backoff and exponential backoff, to be specific, with Jitter. It becomes very reliable and fault tolerant. So here is what I call with Jitter and backoff function, where I've combined delay and exponential backoff with Jitter. So here, as you can see, I have most of the function is same. It's just the delay part that is keeping on changing. So here the wait time is calculated by delay seconds into 2 to the power of attempt into the random integer that we're choosing. Now I should actually reduce it significantly because the delay might go insane numbers. So I'll just keep it 1 to 5. Now with this approach, we are combining exponential backoff and Jitter together, and it becomes really unpredictable while also keeping the delays high, and that makes it very very robust and very reliable. Now let's try exponential backoff with Jitter. Okay, with backoff and Jitter with other function name. Okay, let me just copy paste it. Now let's retry this particular function. Okay, I should actually print the weight here as well, so we know how much weight are we expecting. I'll do that here as well, or let it be. I will just, yeah. Did I not save it? Yeah, let's try again. Yeah, it is waiting 1 second, and okay, wait for 4 seconds, 10 seconds, and okay, it will take a lot of time. I should just, okay, we can make it a bit better actually by capping it. We can also introduce a new variable called cap, which will be the maximum amount of seconds that we want it to, delay for. Let's call it 8 or maybe 7. We don't want it to exceed the capacity, the cap we are setting it. So when we head over to here, we'll do something like min. We have this cap, whichever is minimum, it will take that and wait for that particular time. This makes it a little more, cleaner, and we don't have to wait for very long. I'll just also call cap here. It will choose the minimum number, and what is this warning? Oh, okay, my bad. I should have set up min here, and also I should have set the cap here as well. Something like that. Yeah, I guess that's it. So this will help us cap the amount of seconds to a particular number, so it does not exceed that. That's it. So because we were getting this 10-second delay, I don't want that. I just want maximum amount of delay to be 7. So let's see it again in action. This time it worked. 4 seconds. All right. Okay, again. Okay, it capped it to 7 again because it might be exceeding the the max cap. Yeah, so that is how exponential backoff works with jitter. Now the delays are bigger, and there is randomness introduced, so this is much more fault tolerant. So far we have talked about what retry mechanisms are, the different type of retry mechanisms, and how to implement them. But there is still one thing left that I want to talk about. That is the decorator pattern of implementing these retry mechanisms. Now, so far what we have been doing is making different type of functions. What I have done is basically create different type of functions, and within those functions I've written the retry logic. But this is not the recommended approach. What we usually go by is a decorator based approach. We create a decorator for retrying a function. This is the traditional pattern that production systems have been using. Even these programming languages come default with. In Java and Python both, we have some decorators who perform these, so that we don't have to implement retry patterns again and again manually. They have given us decorators that we can use on top of function to make it retryable. Now, similarly, I thought why not create a retry pattern of my own. So I created this decorator using functools. Functools is a Python-based library to create decorators. So here we are. I've wrapped this function with functools. So whenever a wrapper function is passed within this decorator, it will basically make it retryable. So what is going on? Basically, it takes in max attempts and delay seconds. Not these are optional because it takes in constants by default. So within the wrapper, it is basically the logic remains the same, that we have a loop, we take the body and we check if the body returns none and do we need to retry or not. And if we do need to retry, we call off the jitter plus backoff based mechanism that we had discussed before. And I've also introduced the cap here as well. So now we have a retry based decorator that takes in a function and retries it. So as you can see here, the call API has been exchanged with this wrapper function. So here is the implementation. I've created this small function called fetch unreliable API, which calls this call API, and on top of that we have this retry decorator. Now whenever I call this function, it will basically automatically act as a retry mechanism based function. So let's try to run it and see it for ourselves. If I do something like this, and yeah, it works and retries a request again and again, and you can see the delay is a mix of jitter and backoff as far as what we have written is concerned. And yeah, we have gotten our success status after 4 times of attempts. So this is the decorator pattern with retry mechanisms. In this video, we talked about what retry mechanisms are, different type of retry mechanisms and how to implement them, the essence behind retry mechanisms. And we even talked about the decorator pattern that comes along with retry mechanisms and the recommended way to implement retry mechanisms. But that's not it. you need to implement these retry mechanisms and patterns on your own to understand it even better. I will even link an Amazon blog in the description, which you can refer to. It discusses the different type of patterns and how one is better over the other, and even plots it on a graph to understand it better. It will open different horizons for you to understand these patterns even better. And you should dig down even deeper in reliability engineering, because it is very vast and it is very cool and amazing. And yeah, so that is it for the video. Till next time. So bye bye.